Hello, my dear students. So today we are going to discuss about the cell of an atom, the capacity of cell to hold electron, different subcells present in any cell of atom, and also the capacity of the subcells to hold electron. And we will also discuss about the 2n square rule, which tells us about the total number of electron that can be accommodated in any cell of atom. So let us talk about the cell. Cell also known as orbit. And here, if we have an atom, suppose there is an atom where in the center of atom there is nucleus. And around that nucleus, there are certain fixed elliptical path in which electrons revolve. So suppose this is the first cell, second cell, third cell, fourth cell, fifth cell, and there may be more than 5 cells also. So all these are cells. This is cell number 1. Cell number 1. This cell number 1 is also known as K cell, whereas this is cell number 2. Cell number 2, also known as L cell. Third cell, known as M cell. Fourth cell is known as N cell or fourth cell. Fifth cell is known as O cell, and so on. And this is what? The nucleus. As we know that in the cell, electrons revolve. Now, in every cell, what are the subcells and what is the capacity of each cell to hold electron, and what is the capacity of the subcells present in each cell to hold electron, we will discuss one by one. Now let us take the first cell, cell 1 or K cell. K cell or cell number 1. If cell number is 1, that means the value of n is 1. Now, according to 2n square rule, we have 2n square rule to find the maximum number of electrons that can be accommodated in that cell number 1. So, here number of electrons that can be accommodated in K cell is equal to 2 into, here by using this 2n square rule, 1 square. That means 2 into 1, it is 2. Similarly, if we have to find the number of subcells present in this K cell, then we can use the formula number of subcell is simply given by the value of n. Since the value of n is 1 in case of K cell, how many subcells are possible here? only one subcell is possible in case of K cell, and in the K cell there is only one subcell, that is S subcell. Now if we take another cell, second cell, then second cell is the L cell, where n is equal to 2. So what will be the number of electrons that can be accommodated here in the L cell? Number of electrons is equal to 2 into n square. N square means what here? 2 square. It is 2 into 2 square means 4. That is why 2 into 4. Maximum how many electrons can be accommodated in the second cell? 8 electrons can be accommodated here. Now what is the number of subcells here in L cell? Number of subcells is given by the value of n. Since the value of n in case of L cell is 2, what will be the number of subcell here? 2 subcell. Now the 2 subcells present in L cell are S and P. You know here the capacity of S subcell to hold electron is 2, whereas the capacity of P subcell to hold electron is 6. That is why total number of electrons present in second cell or L cell is how many? 2 plus 6, it is 8. Similarly, if we take third cell, that means M cell. M cell, the value of n is equal to 3. So what will be the total number of electrons that can be accommodated here in the third cell? It is also given by the 2n square rule. Number of electrons is equal to 2 into 3 square. Here 3 square means 9. So 2 into 9, it is 18. In third cell, we can keep maximum 18 electrons. Now what is the number of subcell here? Number of subcells in third cell is equal to n, that is 3. So in n cell there are 3 subcells. They are S, P and D. As we know that the capacity of S subcell is to hold 2 electrons. Capacity of P subcell is to hold 6 electrons. Now remaining how many electrons we have? Total 18. Out of 18 already 2 in S and 6 in P already accommodated, remaining 10 electrons. So D subcell can hold maximum 10 electrons. Now fourth cell is N cell. N cell, how many, what is the value of N in case of N cell? N is equal to 4 since it is fourth cell. So number of electrons is equal to number of electrons in N cell, that means fourth cell, is equal to 2 into 4 square. It is equal to how much? 2 into 4 square is 16. So 16 to the 32. It can hold maximum 32 electrons. Now number of subcell is equal to what? Number of subcells in this N cell or fourth cell is equal to n here, and the value of n is 4. So it has 4 subcells. Now what are those 4 subcells present in fourth cell? That is S, P D, and F. As we know that the capacity of S is 2, capacity of P is 6, capacity of D is 10. Now, total how many electrons it can hold? 32. Out of 32, 18 already we have, remaining 14. So, capacity of F subshell to hold electron is 14. It can hold maximum 14 electrons. Now, if we take fifth cell, that means O cell, O cell, the value of N is equal to 5. So, what will be the maximum number of electrons that can be held by this fifth cell? Here also we can apply 2n square rule. Number of electrons is equal to 2 into 5 square, that is 5 square is 25, 25 to the 50. And how many subcell it may have? So number of subcell is equal to subcell is equal to n, that is 5. So here, what are those 5 subcells present in this O cell or fifth cell? The 5 subcells are S, P, D, F, and G. Here one thing I would like to tell. Actually, this G subcell is only theoretical. Till now, it do not exist. So, we can remember up to this fourth cell, the maximum number of electrons that can be held by the fourth cell is 32. But maximum number of electrons that can be held by fifth cell is 50. But in fifth cell, there is one subcell, that is G. This G subcell is just a theoretical subcell. It do not exist in reality. Till now, it is not found. If we talk about its capacity, then it can hold maximum 18 electrons. F subcell 14, D subcell 10, P subcell 6, and S subcell 2. In this way, if we add them, then we get 50. But in reality, this G subcell do not exist. So, we have to remember all these cell, subcell, their capacity to hold electron, and we must use this 2n square rule to find the total number of electrons present in any cell, or total number of electrons that can be accommodated in any cell. So again, I will repeat one thing, that is, in fifth cell, theoretically it can hold 50 electrons because it has G subcell also, but practically it is not found till now. So up to fourth cell, if we remember, then it is enough to write the electronic configuration of any element that exists in reality.